Powers of monomials. So what happens when we have a power and it's raised to another power? So to raise a monomial, to a power, use the power of a power rule. Now, sometimes you'll hear this called just the power rule. There's also, I think, power of a product. And that's where it gets kind of confusing because yesterday was product of powers. Let's see where I put it. Yeah. So yesterday was the product of powers. What we're looking at today sometimes is called power of a product. I don't use that because even I have to think about it for a minute and remind myself which one means what because there is a difference. So I call it power of a power or the power rule. And basically the way this looks is you have a power, right? Together, this is a power. The base with the exponent makes the power. So you have a power, or this is a monomial. Okay, so here's your monomial. You have a monomial raised to a power. Power of a power. When you have a monomial raised to a power, what you end up doing is you end up multiplying the exponents. So here we have a power raised to a power. We keep the base and multiply the exponents. Now, what's nice is you guys do have, open note quizzes and things like that. So you will be able to have access to these different rules. At the end of the week, once we've gone through all of the properties, I'll have you create kind of a reference page. Because things will start kind of crisscrossing. And that's partly why, with the way I showed you guys how to do the work yesterday, it helps keep everything kind of organized. Because now we're in a situation where yesterday we were multiplying powers, but we added the exponents. Now today, it doesn't look like there are any operations, but the way this is set up, now I have to multiply the exponents. So you guys can probably see how keeping track of all the different little things can get a little tricky, right? So while you're doing your notes, please make sure that, whatever work you see me do, you do. And know that we will create a reference page on Friday. So our first example, x to the second power to the fourth power. Now, according to the rule here, if I have a power raised to another power, I'm going to multiply my exponents. So this is going to become x to the 2 times 4, which is x to the 8th. Now, of course, you could take my word for it that this is the way it works. Maybe you remember from 7th grade, seeing this rule. I always like to show where this comes from and why it works, because if for some reason when you do take the test, you can't find the notebook, Google doesn't work, you can't remember, I want you to be able to fall back on the basics of exponents if you have to. And I do just like as much as I can showing, why these things work the way they do. So if we think about this, x to the second power to the fourth power. If we think about this is just a base, right? This is just a base to the fourth power. So this is like saying x squared times x squared times x squared times x squared, right? X to the second power to the fourth power. 1, 2, 3, 4 multiplied by themselves, right? Now, if we think about what we did yesterday, what you learned yesterday, if I'm multiplying the same base, I add my exponents. So just one little conversion here, expanding this out a little bit, and I can actually use yesterday's property to say keep the base and add my exponents. 2 plus 2 plus 2 plus 2 is 8. Now, if I want to take it a step further and I want to expand all this out, and you don't have to write this down, you can just watch, by the way. So if I were to expand x squared, I end up with 1, 2, 3, 4, 5, 6, 7, 8. X times itself 8 times, x to the 8th power. So this is like the scenic route to our simplified answer. This is using the power of a power rule. And if all else fails, if you forget what the rule is, you can always think back and say, okay, well, this base is to that power. So x squared 4 times, x to the 8th. Another way sometimes students will look at this, they kind of imagine that it's kind of like this is a distribution. And distribution is just a multiplying property, right? And we are multiplying here. So they kind of picture themselves kind of distributing this exponent to the exponents inside the parentheses. So that's another way you can look at that. So let's look at another example. So now let's look and see what happens when in the parentheses there's more than one power. So m to the 7th, n to the 4th, all to the 4th power. So we could imagine this is our base, and this base is put to the 4th power. So it would be like I would have 4 of these being multiplied. I could go through this whole crazy thing, but at this point, like, that's going to be a lot. So I can look at this and say, okay, well, a power to a power, I need to multiply my exponents. So I could apply that here to the m to the 7th, right? 7 times 4. But then I also have the n to the 4th. And since they're bound by these parentheses, that means everything inside the parentheses is to the 4th power. So the m to the 7th is to the 4th. So is the n to the 4th. So it's almost like this exponent 4 kind of distributed inside. It's not the distributive property, so you don't want to say, it distributes. But ultimately, that's probably what it will remind you of. Right? And then we just multiply and get our simplified expression. Example 3. Let's see what happens on something like this. So in a case like this, We haven't done an example where the variables did not have an exponent showing. So that can make you a little nervous, like, I don't know what to do. I haven't seen that in this case. However, what we have seen is we have seen variables without exponents listed, and we've gone in and remembered that the exponent is actually a 1 if we don't see it there, right? Power to a power means that everything inside is to the third power, so c to the first power is to the third also, and d to the second power gets taken to the third power. So I get c to the 1 times 3 times d to the 2 times 3. And now if you left that off there, that's okay. As long as you have this part of the work, you'll be able to look back when you have a problem that maybe reminds you of this. You can look back and see that, okay, well, there was no exponent here, but I multiplied 1 times 3 because of the 1 that we just don't see. C to the third, d to the sixth. Now, the next set of examples, we're going to be looking at what happens when we have coefficients, okay? Because these examples have just been straight variable bases. So what if we have coefficients? So if you have coefficients, if the coefficient is grouped and to a power, raise the coefficient to that power. Then simplify. Now, it is kind of hard to find the right words to describe what happens here, so if this doesn't make a ton of sense, it will in just a minute. So copy that down, and then we're going to look at an example. Okay, so here's our example. Example 4. 5x to the 7th power, all to the 2nd power. So if the coefficient is grouped and, maybe it's grouped and raised to a power. I don't know, maybe raised. I'll have to kind of see after you see this what makes most sense. But if the coefficient is grouped together with the power, so what I was trying to say is if your coefficient is inside the parentheses to the power, then that coefficient is also raised to the power. So because the 5 is bound by the parentheses, it also gets the power of 2. So make a little note that says everything within the parentheses is to the power of 2. So the 5 is to the 2nd power, and x to the 7th is to the 2nd power. And we can't forget that even if I don't see an exponent, there really is a 1 there, right? So this would become 5 to the 1 times 2. x to the 7 times 2. Now, when the instructions say then simplify, what that means is that after you multiply and you get 5 to the second power, you're not done. You do need to multiply that out and get 25x to the 14th. So now this instruction here says if the coefficient is grouped and raised to the power. So what happens if it's not grouped? So what if it looks like this? Okay, so if we have something like example 5, whatever's inside the parentheses is to the third power. This 2 outside is just being multiplied by whatever's happening after it. This 2 has nothing to do with the third power that we have happening here. Basically, what's going to be happening, and we're going to start seeing it on the next few examples, we ultimately just follow the order of operations. Okay, if we think about the order of operations, I look inside the grouping symbols to see if I can do anything. Okay, I can't do anything inside, right? So I can't do anything inside the parentheses here. So I'm going to look outside for any exponents or powers, right? So I'm going to ignore this, and I see that I have a power here. Can I do anything with that power? Why, yes, I can. I can take that power and I can apply it to each of the exponents inside the parentheses. And by doing that, I'm going to break the grouping up and be able to work on everything else in the problem. So I get 2 times 3 to the 1 times 3, x to the 2 times 3. 2 times 3 to the third, x to the 6th, which becomes 2 times 27 times x to the 6th. Because we do want to simplify these powers down. 54x to the 6th power. Just a couple more examples. 3 more. So on this next one, so we've got a coefficient inside, we've got a coefficient outside, and one inside. Now let's look at what happens when there's a negative coefficient. Now we saw what happened when there was like a negative with a variable, like negative c. We saw that yesterday, right? Where if you had like negative c, it was really negative 1c. Well, in this case, it's just a negative 5, right? So make sure you remember that if it's in parentheses, these are bound together, and everything inside has the power of 3. So everything is to the third power. The negative, the 5, the x to the second, like everything. The only thing is you wouldn't really say like the negative sign is to the third power because it's negative 5, right? So negative 5 is to the third power. So when I give everything the third power and I rewrite it down below, the negative 5 is to the third power. right? So negative 5 to the first times third power, 1 times 3. Now, it's important that I put the negative 5 in parentheses. Technically, in this case, I would get the same answer whether I did the parenthesis or not. However, that only works half the time because technically, I just said technically again, but this time for like actually technically, if you don't put the parentheses around this, you're not correct. Even if the value of the end result is the same, your process is wrong. And your process is only going to work half the time. The negative is bound to the 5 because of the third power. Okay, so when I work through this, it's the same thing like we've talked about since the beginning of the year. Negative 5 to the third power. These are two different situations. In this case, the negative 5 is to the third power. In this case, the 5 is to the third. The negative is just telling me that my result is going to be the negative version of whatever I get. And the reason that this is the way it is because of this power of a power. Everything in the parentheses is to the third power, and it makes this negative 5 times negative 5 times negative 5. Over here, it's negative 5 times 5 times 5 because of the parentheses. Okay, so it kind of comes back to haunt us here. So having said all that, I get negative 125x to the 6th. And on a side note, usually on like a test or a quiz, there's a very good chance that the number you're going to get here is going to be in such a way that if you don't know how to handle this type of situation, you're going to end up with the wrong answer. Just a heads up, because we want to, make sure that we know you guys can do that correctly. The last thing that we're going to run through are two examples of a mixture of yesterday and today. Okay, so now we have a mixed practice. So we're going to combine product of powers with today's power of a power. Okay. So we have the quantity x times y squared, all to the third power, times x to the fourth, y. The biggest piece of advice I can give you is follow the order of operations. The order of operations never changes. We just start adding to the sections, right? Or we start explaining a little more in depth the different parts. So first step is always grouping symbols. We look inside the grouping symbol. Just double check in the grouping symbol that there's nothing we can do. There's nothing I can do with x times y squared. It's just going to stay that way. Nothing I can do. So then I want to look at exponents. Now I know I have a bunch of different exponents here, but when we look at the second step with the powers and exponents, I want to look at this and say, okay, is there an exponent somewhere that I can use to start simplifying something? In this case, it's the 3. So this 3 can be applied to the exponents inside. So I'm going to follow the power of a power rule. So my power of a power rule tells me that I can take this exponent is keeping the grouping symbol around these two. So if I multiply by what the power's inside, I can get rid of it. So I get x to the third, y to the sixth. Now I'm skipping the step where I write out, the operation. because maybe you're at a point where that you're comfortable with that. If not, that's okay. Write out that extra line. So by completing the power of a power, I'm able to break out of the grouping symbols here. And now I end up with a problem that looks like yesterday. Now all I have is multiplication between x's and y's. So now I'm going to use product of powers that we did yesterday to take my x's, and because I'm multiplying the same base, I'm going to add my exponents, right? So x to the 3 plus 4, y to the 6 plus 1. I get x to the 7th, y to the 7th. And if I look at the properties that I did, power of a power is an exponent type property. Product of powers is a multiplication. Like product is a multiplication word. And if we think about the order of operations, exponents, then multiply and divide, add and subtract, right? If I had any addition here, I would combine like terms. So with today's mixed practice, you want to focus on the order that we did this. Is there any power of a power that you can do? Do the power of a power first, because it's an exponent, step 2 of the order of operations. Then handle the product of powers, which was yesterday's activity. All right. So I do want to do a couple more of these. However, I'm trying to get you to get your homework. So what I'll do is I'm going to give you guys a few minutes to kind of either get settled, go, whatever. And if anybody wants me to do a couple of the more intricate problems on the homework, I can do those here. Everything is opened up in Canvas. Please make sure you read the instructions, because you are kind of doing scattered problems. But that's it, you guys.